we're going to go into our second presentation by Stphen. I'm sorry. We talked about it, and I messed it up, you know. That's so embarrassing. From Riedel, who will tell us about the adapting control rooms to existing infrastructures, because not everyone are privileged to work on the greenfield approach. So Stphen, tell us about how they can address that.
Sure. Thank you. Yeah, pleasure to be here, everybody. Thank you. The topic I'd like to talk about, it's the idea of modernizing control rooms, and particularly for scenarios where you have sport and entertainment companies that have historic venues, arenas or stadiums, and the idea of, you know, you get to a point you have to modernize or you know, your control room, and what are the strategies to update and upgrade that control room while at the same time trying to leverage whatever existing infrastructure you have in that arena, with the technology, the edge device equipment, and core routing infrastructure. So I just realized, I gotta be able to go from slide to slide here. So if I can, yeah, there we go. Okay, so the topic we'll get into pretty much what is the problem that we're trying to solve here with a sports and entertainment company that has a venue where, you know, you're trying to modernize and improve on your audience engagement and experience. And it boils down to, you know, the challenges that you're faced with, the constraints that you have. And that's going to be then driving your business requirements to a certain degree. And then from there, you can develop a solution or, you know, think about a solution, the design criteria, the pros and cons of that design criteria, and of course the cost impact. So once you have that information and you have some strategies on modernization, you can then get an idea of the overall solution and what could work as a cost-effective solution in terms of modernizing your control room and adapting it, of course, to the constraints of your venue. So once we analyze that problem and the solution, we can then look at that from another perspective, from a practical experience for some sample customers and what they decided to do. So at the heart of this all really is you know, the problem and the challenge that we're trying to face here is, you know, you have a control room, right? It's becoming obsolete. And what does that mean? You know, at the heart of it is your core routing, audio video routing solution. And it's, you know, traditionally it would be a baseband router, that handled both, you know, baseband, SDI, video and audio. It can be an arena or stadium, and this is the focus of the presentation, basically in a so I would consider a medium scale type of size solution. You need this core routing infrastructure system and control room, obviously for your live production events, your sports events, your hockey games, your basketball games, or your concerts. And, you know, your business as a sports entertainment company is driven by, you know, the events that you can host in that arena or stadium. And, of course, then you have to upgrade. And the upgrade has to happen because you've reached a point of end of life of the product or end of support in a way. You can no longer get equipment repaired. The support is non-existent for the certain software for your products that's being used. And you have a variety of other challenges as well, like you can't get, you know, support for additional or higher resolution signal formats and newer equipment and workflow functions. So you have to ask yourself, okay, great, we need to upgrade. If we reach a point where it can't go any further, what are we going to do? And of course, why are we doing this? How are we going to do it? When, where? All the 5 whys have to be asked. And of course, you have the challenges, the constraints, right? You have a historic venue. You're not about to abandon it. That could be, you know, a hockey arena in downtown, a basketball arena downtown, a stadium, soccer stadium. all, perfectly suitable for sporting events. It's just that the internal guts of it have to be overhauled. And that includes the technology, and obviously driving all this is the live production workflows. You might want to do, there's always a key factor in a sports event, because you can do stuff, the audience can experience stuff at the event that you normally can't experience on television. And so you want to be able to engage audiences that way. And that, underlying all this, of course, is you want to do the most cost-effective solution. And what does that mean? Like you basically want to take all your infrastructure, analyze it, and see if it can be reused. And that includes the space, the facility, the wiring, the actual edge device equipment, the core routing infrastructure as well. All this, in terms of your problem that needs to be solved, and how you're going to address these problems with the best solution possible. Okay. And we also have to remember that you have the construction, spacing, energy, and cooling requirement. New equipment requires new energy, specifications, new spacing requirements. Maybe the facilities, the data centers, or control equipment rooms all have to be overhauled. And of course, that's subject to a budget and schedule constraint, because obviously in sports and entertainment, primarily sports at least, you have it's a seasonal type of situation. I mean, you're going to have, a hockey season lasting, from the fall through spring. And then so you have a summer window of which you can do changes. And if you're going to do those changes, you obviously have to do them in a quick window, maybe multi-year. And of course, underlying pretty much everything is a drive to modernize the solution to leverage the benefits of IP. Okay. So when we talk about IP, there's a dilemma to a certain extent. It's not really a dilemma. It's more like a challenge, because you want to go IP, and there's no doubt about it. It's got the flexibility I'll get into and benefits I'll get into in a second. So the question, you want to go IP, but there's always going to be some technical challenges that we'll get into, and the pricing challenges, of course. I mean, but and can it be done? How and how effectively and how fast? So these are important constraints, and ultimately these drive the business requirements. Okay, the business requirements drive the modernization strategy and the ability to adapt to your facility and its control room constraints. So we'll get into this now a little bit about the business requirements. The business requirements are really about, 2110 is, it's been here now for over 5 years, at least being deployed. It's got some tremendous benefits. We can all agree, right? It's flexible. It's the ability to leverage IT media infrastructure and large bandwidth formats, low latency media formats. You can do a variety of processing functions now a lot more easily. Of course, you can scale very high with media infrastructure, and of course the interoperability is significant. Now separate media essences can be processing and performing workflows in a seamless way that hadn't been possible before. So ultimately the answer, you want to go 2110. And the other factor that's really critical is that you have your edge device equipment, and your I/O count and your capacity, and the size of that I/O component that drives the business requirements as well, right? So you have to ask yourself, how many, if we're going to modernize our system, our control room, and our technology, our topology, what scale do we need to go? What's driving it? What is the existing, let's say, the amount of cameras that we have inside the arena? And also, do we want to go more, to add more cameras? There's aspects of this, audience engagement and the user audience experience that you may want to get more cameras into the arena to capture more and more viewpoints. You want to get more audio sources to literally listen in on the players as they talk, and all sorts of interesting challenges and areas that you want to pursue. And Also, like, you got to weigh the consequences. Maybe you already have existing SDI baseband equipment that you can use. Like, cameras might still be good enough to support, like, better resolution formats already. So can you keep that? You don't have to overhaul and go native IP. And so that you have to evaluate the scale of how many IO devices you need, whether they're IP or SDI. And it's somewhat, of an injustice there where it may influence the scale of and the direction of your solution, whether it's going to be full-fledged 2110 or an incremental approach. So last but not least, by the way, is who's going to maintain the system. Because when you're implementing new technology, I mean, obviously it's 5 years old, but the bottom line is for a lot of people, it's still a baseband. There's still a lot of baseband in this world. And when you're getting into IT, you have to learn a lot of IP concepts, obviously dictated by 2110. And there's a lot of technology and protocols that you need to learn. You got to learn how to handle the new equipment, IT media infrastructure. So what does that mean? Do you need to train your staff? Do you need a new team? Can you leverage your already existing IT department? Do they even have the qualifications to even handle it? And when you put it all together, this is like ultimately the business requirements can be boiled down into three sort of general strategies, right? Defined by these topologies, right? So you have call it a status quo expansion, where you take what would be a traditional core routing system, baseband monolithic core, all SDI IO based, or do you really want to go there? Ultimately, are you protecting yourself for the future? You gotta remember that your goal is to invest in something that'll position yourself for the future, other than just postponing the inevitable and potentially leave you at a worse off situation. So then, okay, well, let's go into the brand new technology, which is the 2110, sort of decentralized fine leaf and distributed architecture, this fabric intelligence that is so useful. That's of course, a really interesting solution that you definitely want to take advantage of. But again, with those previous factors, there's also the learning curve and the new technology adoption, which adds risk. Can you offset that risk? And there's this conceptual hybrids. Let's say a third type of approach. Let's call it a hybrid approach, which could possibly have the advantages of both, like status, the original sort of baseband solution technology everybody knows about, versus a 2110, all the best parts of 2110, including the decentralized fabric nature of it. But that would use both baseband and 2110 incrementally at less sort of aggressive pace. So that's the idea here about the solution criteria. Okay, so right, we got that sort of defined. Let's go into that in a little bit more detail here. So we have our design criteria, right? I just mentioned it briefly. We have that centralized solution, the traditional, core routing infrastructure. You have the decentralized approaches where, including the 2110 and hybrid approach. And, this, as you can tell, has their benefits here. What I've attempted to do in this table is indicate anything where in red, which could be potentially a risk. And, it's an impediment. So you can see, for example, a centralized solution. You really don't want to consider that. But I mean, if hypothetically you have that budget and you want to expand it a little bit, yeah, it's not very flexible and scalable, because you're locked to the frame size, right? And when you get into a little bit more detail with these types of solutions, you decentralized, 2110 solution, the benefit is a spline leaf hierarchy. Great. No longer in one place. You can install it in different locations. Now everything is linked by fiber. It can scale. It's flexible to add IO, and you can go on and on. And let's say you take the hybrid approach. Well, you can leverage this idea of a fabric, but imagine instead you put that sort of fabric intelligence in nodes. So, and you have a mesh topology in a similar way to 2110, but it's primarily baseband driven. So I'd like to imagine that as you're taking a centralized system and you're just taking a backplane, and instead of IO line cards in a backplane, you're taking those IO cards out and you're just simply putting them in a decentralized location, but now connected through fiber. So it's an exploded backplane basically. So when you look at all that, you can start to see some benefits, but let's not forget, of course, anytime you introduce a 2110 solution and new equipment, there's going to be aspects that have to be considered, including timing. So decentralized, 2110 solution has to be using PTP, okay? If you want the hybrid solution to use, have a timing mechanism, well, it's got to do both. If you want to incrementally migrate a hybrid, have a hybrid solution that migrates toward a 2110 approach, okay? So these aspects, and interoperability is critical, right? So in a 2110 solution, it's already native and everything is interoperable. The other systems would need gateways or gateway functionality. If you want to bridge SDI and 2110 worlds, you can have processing functionality as well, whether external or internal. And then you get into other aspects, more mechanical-centric aspects, where you have to be wary of the installation, the rack space, weight, power, cooling, even noise. I mean, when you're dealing with 2110 equipment, it's media-centric, it's data center type equipment. You're dealing, what the traditional core routing solution, yes, is installed in a data center type environment. What if, you could take a hybrid approach and you could, I kind of also have to clarify something here. So because you have a spline leaf topology, you would be distributing the solution, at least in the spine. You could distribute it into different rooms. Okay, but with media equipment, media network equipment, it is data center sort of has to be in an area where you have temperature controlled environments, okay? And the potential there is you can have, higher power requirements, the noise is loud and so on. So you have to be wary of all this. But the point is that this is the design criteria that has to be considered in terms of the changes that are required. Rack space is obviously superior with the decentralized solution, a 2110 solution. And, you can even get potentially even better with this best of both breeds where you're, extending line cards really. Of course, we get to the configuration tools and the broadcast control tools. This is where, the 2110 solution, you get compatibility with NMOS. This is really good. Centralized solution, not really NMOS compliant. It's more, proprietary protocols. Hybrid solution would be both, so that could be kind of a negative. So you get into the further discussion about this, and you'd start to realize, okay, let's look at this from the pros and cons perspective. I mean, we already mentioned the hybrid solution, the monolithic solution, traditional core router. Everything here is baseband related, so you got to remember everything bulky, single purpose cables for individual signals. It definitely doesn't have the benefits of scalability that solution or the other solution will have. So, I get to the pros. Obviously, it's proven technology. You can use the existing cable plant and timing infrastructure and so on. Everybody knows the technology. You can quickly, configure it. The cons are the expansion difficulty because it's not easy to expand. I mean, you got to add another frame. It's in the same location. Your cable, you got to add all the necessary glue and the DAs and the frame sinks in order to get your baseband signals, back to the expansion frame. Installation can be labor intensive. It's not exactly the most resilient solution, but the bottom line, it's understood by everybody. And of course, then you take that sort of diagram and you go into the decentralized approach of the 2110. And these are the elements at stake here, although I will have to mention here that, if it's purely native IP, there's no need for those sort of diamond symbols there indicating, there's no need for those circle icons indicating gateways, because you can just simply go direct to the distribution mechanisms, which are the layer 2 and the layer 3, primarily the layer 2 switching media fabric elements. And so the pros and cons that we talked about with 2110, it's definitely a future-ready solution. It's distributed, scalable, flexible, interoperable, resilient, no question. You got a lot of space and weight savings, high bandwidth, long distance, everything's fiber now, lightweight. I mean, for the most part, you can use fiber, you can use Cat5, but the point is at least with higher bandwidth, you need fiber. So this is where it gets like really, really impressive. The cons are, of course, that there's a data center sort of requirement here. This equipment, it takes power. I'm sure it can, as the technology progresses, it's getting quieter and it consumes less power. So we can all be recognizing of that. But there's definitely different requirements there. It's certainly superior than what's been, a traditional system. But you also have to do the installation of as well. You have to install your media fabric, your cabling, your optics, and of course your timing system, your PTP. And there's a ramp up there. So extensive commissioning and training support, technically to ramp up, there's a lot of material to learn. Okay. And, not only the 2110 standards, audio, video, and metadata, the timing standards as well, the umbrella control with NMOS, and the optical technology as well, and a lot of IT concepts. And if this solution is not a closed loop solution like within the arena or stadium, and there's a tie into the corporate IT network, you will certainly have the IT security dependencies, and you will require a level of scrutiny and analysis that will be very, very critical to make sure is addressed. Okay, and then we get finally to the so-called hybrid solution, where you are extending the line card and the routing core, and I'd like to say, call them the routing nodes. You're extending them as nodes to the edge. And the benefit here is you can leverage the existing infrastructure, your cabling, your edge devices, if they're still supporting all, newer formats and workflows. And you can benefit from this sort of routing intelligence. It's extended, the same kind of routing intelligence that you would have in a 2110 solution. Imagine that you could do that and extend it into the nodes themselves. And you have also the benefits of fiber and optics and transport bandwidth available. You have now shorter cabling, and this allows you to also incrementally then not only you're basically using a core baseband sort of fabric here that's extended or exploded, as I'd like to say, but you could also then include 2110, but in an incremental way. Like you would then have interfaces that could leverage a fabric, but a smaller, IP fabric. So you're starting to, hybridize the modernization. So that's the conceptual idea, at least. And the idea here is that, okay, what are the pros of that? Well, the main pro is obviously it's distributed and decentralized, just like the 2110 fabric. But it also has the non-blocking intelligence that you have in IP, but it's technically not IP. Okay, if it's really just an extended backplane matrix, really. And that also leaves some advantages of some resiliency as well. And you can leverage the existing timing infrastructure before you then get into incrementally integrating 2110. So I'd like to say those are some interesting, pros and conceptual ideas here. And the cons, of course, are now you have to manage two different sort of elements of this system, the baseband I/O and the 2110 I/O, and that requires two different solutions. And so that can be become a problem unless there's some other mechanism to consolidate that. And that leaves us then finally, so we've been analyzing, the design criteria, but of course there's a cost criteria, right, which everybody knows eventually this is really going to be the main force here. But when you talk about the cost criteria, it's all about the CapEx and OpEx costs. And now, obviously I've been working with different customers in over the years, and I'm not going to say, the actual, dollar numbers here. So the idea was just to present a probability of costs for different types of solutions. So red obviously means larger percentage of costs, orange is medium, and white is a sort of a not really a significant contribution. So, I mean, very, very quickly, I mean, the purchase of equipment is the main driver of cost here with the decentralized solution. But there is some aspects, of course, with you have to tear down the old infrastructure and redesign your rooms to accommodate the data center requirements that would be necessary for a media-centric 2110 solution. There's somewhat, less cost, but there's still, important costs with, no matter what solution you choose, you're going to have to buy the equipment, which is, at its most important. Anything with processing and routing functionality is going to cost you, a lot of money. And of course, if you want to make everything interoperable, you have to have gateway functions, because honestly, is anything possibly purely native IP at the moment? Can you go native IP just to start with? You can go almost, but in our experience, like, you're going to have roughly, I would say, an 80% native IP solution, but you go, in the context of a control room and an arena and a stadium, you're going to have those outside broadcast trucks, right? The OB trucks, not all of them are native IP, so they'll still be using baseband, for example. So you'd have an 80-20 type of scenario, right? And so you will need gateways ultimately, no matter what. And some solutions, you may have baseband, and then some trucks will actually be IP. So you have to have that sort of crossover, and there's always going to be those functions. So that could be a significant cost. If conceptually you can incorporate, those functions into your nodes, that in theory could be a lesser cost rather than an external gateway function. But you can see that ultimately that functionality and then processing functionality, you want to get into handling all your media essences, that adds significant costs, okay? You have to obviously purchase the services and to support. There's an initial cost just to do that, and that includes training and service level agreements. You have to purchase cabling, new cabling, of course, fiber. With the fabric, 2110 could be a larger percentage of costs. It might be a little bit less with a decentralized hybrid solution if you can get more, bandwidth in a more efficient way, but that's all debatable. And ultimately, you would also have more Cat5 cabling of everything being networked. And the other thing I want to mention is when you get into the actual services of actually doing the deployment, you have, I should say deployment. You have to separate the services into the actual, you purchase the services, but when it comes to deploying and actually implementing, this is where time is money, right? So you got to install, and then you got to commission, you got to do your launch, and then you got to do your training. You got to also have the soft costs, right? You got to support it over the long run, and your utility costs. This could be causing some more costs for you, and then depending on the solution you choose, right? But, with the 2110 solution versus the other solutions, you're postponing the inevitable, costs that you're going to have to adopt if you want to support newer workflows. So when you examine all this, you have to really just analyze, as a your company, okay, what is best for us? Like, is there any one-size-fits-all solution? What is our sweet spot? What is our ROI? So you can look at all these costs and based on all this, you can put together a list of pros and cons. And, this slide here just gives you an idea of, the various aspects of each solution, the pros and cons. I think there's no question that even though, it may seem like there are a lower list of cons versus a higher list of pros here, that doesn't necessarily factor into an equal weighting of costs here. So, and ultimately though, no matter how you spin it, your nodes and your fabric are going to be the higher costs along with your fiber and your optics. Okay. So, 2110 also, it's a ramp up. So that's something, not to be underestimated. That ramp up can be sort of incrementally adopted with this hybrid approach, but you have to be wary of the different costs at play. So when I look at all that and we factor it all in together, I wish I could say, well, I mean, I don't necessarily wish I could say, but I mean, ultimately you have a choice to make, and is there a one-size-fits-all solution? No, based on experience that I've seen. And people have different, investments, experiences, customers. So I'll start off with a good example here. So, and I was fortunate enough, I'm from Montreal. I had a chance to deal with the Montreal Canadiens, the CH Group, which is the sports organization that owns the Montreal Canadiens Hockey Club. They also own a bunch of other sports franchises as well, but specifically for the venue downtown Montreal, they have the Bell Center. I also had to deal with the Maple Leaf Sports Entertainment for the Scotiabank Arena downtown Toronto. And, interestingly enough, they've both gone through a modernization program, and the solutions that they have adopted were different. The Montreal Canadiens, interestingly enough, went a full 2110 solution. I would say it's 80%, 20%. They still have to deal with the outside broadcast plant. Where it was interesting with the Montreal Canadiens is that they had examined some other customers, some other, sort of a broadcaster, and seen and allowed them to and sort of got an idea of the experiences that they had to go through before they went and decided to adopt a 2110 solution. So they leveraged somebody else's experience before they went full 2110, and they got a really elegant solution there. The Maple Leafs, on the other hand, they had invested heavily already in equipment, but both customers, interestingly, both companies had a core baseband routing solution. And so they all had the same sort of beginning, at least from a core IO routing perspective. But then the Maple Leafs had cameras, and they already had baseband cameras they had already invested in, which could support 12G and 3G. So they said, okay, we don't need to necessarily go full 2110 right now, but we can go with this nodal approach of edge processing and routing. So interesting choice of solutions. And of course, there were cost differences. I mean, the Montreal Canadiens spent a little bit more money on the 2110 solution. I'm not going to get into all the numbers, obviously, but it's a fascinating topic. And again, not really one size fits all approach here, but an interesting choice. I will mention though that the Maple Leafs, it was less turn up time and less ramp up time, as they were really more of still a node-based fabric, with still leveraging their existing infrastructure, baseband infrastructure. So I thought that was interesting. I thought maybe this would be something of a subject that everybody could be aware of how 2110 gets adopted across at least the sports and entertainment industry with these historic venues. So hope everybody enjoyed that, and if you have any questions, be happy to answer.
Thank you, Stphen. Unfortunately, we don't have time for questions right now, but do catch Stphen at the coffee break. That is after our next presentation. Thank you very much. You may want to click to the last one where they have your contact details, I guess.
Oh yeah, of course.
Oh, no, I'm sorry.
Oh, what happened there?
No.
Okay, somebody just loaded the presentation.
Okay, just find this gentleman in the coffee break. He will tell you everything you want to know. Thank you.